So we really encourage clients to really think about all of the different possible water in their system and how they could kind of prioritize which one is and how to use them all together symbiotically, right? So it all starts typically with more passive, looking at the site, the grade, the slope, what are the options, what's the soil like, how can you slow that water down and soak it in the soil? Then, what are the current structures or possible water harvesting surfaces? And then what are maybe possibly future ones, right? If you're going to build a house or build another chicken coop or a barn or something, looking at what those possibilities might be in an active water catchment system. And then you have this perennial water flow through your house, right? From the sinks and the shower and the laundry. And then how are you going to use that water downslope of your house or outside, right? That gray water reuse. How are you going to clean that water up and make it, have it be another source of irrigation for your edible and permaculture food forest? Typically, we'll get a topography map of the property and then the layout or the design of the house. If they haven't built the house yet, then what their proposed roof plan is. We might have some input about different materials they might consider. The metal roofing is basically the cleanest surface to capture off of. We'll often push for that if they're going to go for active harvesting. Obviously, the cheapest and most economical and lowest maintenance system is passive water harvesting. We'll really push the client to look at that and see where all of our opportunities are to infiltrate rainwater as high as in the landscape as possible, or concentrated in areas that they're planning on growing more crops or plants. The passive harvesting is very important. And as much as we can do by gravity means, if we can have a structure that's high in the landscape, a barn or a carport or something, we can capture water off and have above ground tanks there that can gravity feed down to the house or to the irrigation system. That's obviously our preference, right? Because we're going to save on materials, we're going to save on pumps, we're going to save on electricity use, and it's going to be more economical. If we have to use a below ground cistern, that's kind of our last choice, but it's often that clients want that because they don't want to see the above ground tanks, or that they want to use that space above the tanks for something else. Then that would be another option for us, is the below ground tanks. And that's typically last option just because of cost and the amount of plastic involved and the amount of pumps and servicing and maintenance in the long run. To figure out the calculations, we'll do a survey about what is the client going to use the water for? Are you using it just for irrigation? Are you bringing that water back in the house for domestic use? If so, what's the demand? So how many gallons per day do you need, either on the irrigation side or other uses? And then what's your supply? How much annual rainfall do you have per year, times how much square footage of surface area that you have to capture water from. And with my big overhangs on this house, we're about 3,200 square feet metal roofing that's going into the system. So then that gives us our supply. So that 3,200 square feet times my annual rainfall, which here is about 15 inches. So that's about 1.25 cubic feet of water per square foot of surface area. That comes to, at 15 inches a year, about 29,900 gallons. So just shy of 30,000 gallons. In my climate, because there's kind of 2 wet seasons and 2 dry seasons, I will be using the water in those dry seasons between the wet seasons. The most optimum size for the tanks is about 25 to 35% of your annual. So my optimum in a 30,000 would be maybe 7,000 gallons. You also have to take into consideration what's your budget. So what can you afford when you first put the system in? So it would be great if I could even increase my system, right? My system's 5,100 gallons, but it would be more optimal if I had more like 7,000. So that could be something to think about, is adding on tanks in the future if you can't afford the optimal size system in the initial construction. We try to encourage people to use water in several ways. Definitely the gray water is an important piece. If you have a house, you're going to almost always have some gray water, whether from laundry or bathing or any of those sources. That's one piece that we always try to include in a design or to help give input with the house architect. Some people have health concerns or qualms about using black water or gray water, especially black water. We just really try to explain that it's all about how you either treat the gray water, black water, how to use that water in the landscape safely so that their pets or their children or no one could possibly get exposed to the bacteria. To do that, what we suggest is everything, just like the codes require, is that all the gray water, black water systems have to be subgrade. In my system, it's a drips irrigation system, and that's below grade. So that's in the soil, and we're putting that gray water in that top 1 foot of topsoil where it's most biologically active area of the soil that has different soil microbes and bacteria and things that can help break down and use those nutrients and clean up the water and make that water and those nutrients available to the plants. That's another really unique thing about gray water, is getting that water up into the bioactive part of the soil instead of just, most septic systems are just putting that water quite deep, maybe 2 meters, like 5-6 feet in the ground, where you're kind of below most of the biological activity in the soil. And then you're just relying on the mechanical filtration of the soil, the gravel, the sand. So if we can get that nutrient-dense water up into the root zone, we can provide it for the plants and also be cleaning that water up before it goes back into the aquifer. For small gray water systems, residential systems that are less than 200 gallons per day, in New Mexico, you don't need a permit at this time. For larger commercial systems, you would need a permit and an inspection and a design plan. So as long as you meet those basic safety goals of having it subgrade and having it sized correctly, you won't need a permit for that here. For rainwater harvesting, we've done a lot of advocacy over the years from people like Nate Downey and Melissa McDonald from Santa Fe Permaculture, and our local politicians that we've invited to permaculture meetings and water harvesting presentations. Now, in the last 5 or 8 years, if you build a house in Santa Fe County or Santa Fe City, you are required to put in a rainwater harvesting system if the house is over 2,500 square feet. If it's under 2,500 square feet, you still have to slow and infiltrate at least a 1-inch rain on that site. So you have to passively infiltrate that rainwater and not allow it to go onto the street or to the neighbors if it's under 2,500 square feet. And if it's over, then you need to have a rainwater harvesting system, active cisterns, and then that overflow needs to also be passively harvested and infiltrated into the soil. What's been fun and interesting in Santa Fe as well is it's a smaller community, and we have some really a good group of local small businesses that are really focused on permaculture, rainwater harvesting, watershed restoration. We've created more of a collective where we help each other out, give each other work, meet together and talk about different products or solutions or brainstorm new ideas or projects. And also sometimes do group presentations to inform the public and increase outreach to the community, inviting city councilors or county commissioners or people like that could be influenced by seeing the benefits of rain gardens, rainwater harvesting, passive rainwater collection and infiltration, slowing that water down in the system, pushing it into the ground to help recharge the aquifer and reduce soil erosion, reduce sediment in our rivers, and increase wildlife habitat and biomass production. Just encourage you to go out there and get started in your community, right? You can start at your own house and then reach out to your neighbors, talk to your city councilors, encourage these types of systems to be part of maybe the code for building, or at least awareness, right, for city planners. To me, it's just amazing, like, okay, we have in rainwater, we have this purified water that's falling from the sky, right? I mean, there's so many benefits from it, right? You can see how plants really respond better to it. Slightly acidic. In the Southwest, our water is typically more alkaline, right? So it helps balance the pH. It's falling through the sky that's majority nitrogen, so it picks up little bits of nitrogen. It's just like natural fertilizer. It's mineral free so that it marries well with gray water, because the gray water is going to have both minerals from possibly the well water, but also from soaps and detergents, right? It's going to have other minerals, so it helps balance that water out. And there's just so many benefits to slowing and infiltrating rainwater and using it in our landscape and using it in our houses. So I would just encourage you to get out there and capture your rain, slow it, spread it, sink it. Be an advocate for smart water policies and water reuse systems in your community.